Hello everyone, welcome back. In the previous video, we solved this GATE ECE 2021 PYQ using the superposition theorem. Now, let's solve the same problem using nodal analysis. This time, we will see that nodal analysis allows us to solve the circuit much more directly. We need to find the value of V0 rounded off to one decimal place. So let's take the bottom node as the reference node or 0 volt. The left node voltage is already given as V0 and let the right hand node voltage be V1. At first, let us apply KCL at node V0. We will take currents leaving the node as positive at node V0. The current through the left 1 kilo ohm resistor is V0 minus 4 divided by 1 kilo ohm. And how did we get this value? Let the voltage across the left resistor be VR. Since the voltage at the node V0 is nothing but V0 itself, the difference in the voltage between V0 and VR is nothing but 4 volts. Therefore, VR is nothing but V0 minus 4, and if you want to get the current through the resistor, it is given by V0 minus 4 divided by 1 kilo ohm. Next, the current through the middle 1 kilo ohm resistor is V0 divided by 1 kilo ohm. The current through the right 1 kilo ohm resistor is V0 minus V1 divided by 1 kilo ohm. The 6 milliamperes current source points into the V0 node. Since we are taking currents leaving the node as positive, its contribution is minus 6 milliamperes equal to 0. Notice that this equation contains two unknowns, V0 and V1. Therefore, we need another equation. Apply KCL at node V1 to obtain a relationship between V0 and V1. The current through the 1 kilo ohm resistor from V1 towards V0 is V1 minus V0 divided by 1 kilo ohms. But current sources leave node V1, so their contributions are 6 milliampere plus 2 milliampere. Therefore, V1 minus V0 divided by 1 kilo ohm plus 6 milliamperes plus 2 milliamperes equal to 0. Hence, V1 minus V0 divided by 1 kilo ohm equal to minus 8 milliamperes. But the first KCL equation contains V0 minus V1 divided by 1 kilo ohm. So, reversing the sign, V0 minus V1 divided by 1 kilo ohm equal to 8 milliamperes. Substituting it directly into our first KCL equation, we obtain V0 minus 4 divided by 1 kilo ohm plus V0 divided by 1 kilo ohm plus 8 milliamperes minus 6 milliamperes equal to 0. Multiplying throughout by 1 kilo ohm, V0 minus 4 plus V0 plus 8 minus 6 equal to 0, and hence V0 equal to 1 volt. Since the question asks for the answer rounded to one decimal place, V0 equal to 1.0 volt. So for this particular problem, nodal analysis provides a much faster solution. That's all about this video. I'll see you in the next one.